Okay, here we're writing each expression in radical form. Um, Something that you need to know about rational exponents or fractional exponents is that whatever's in the numerator, in this case the 2, that's what you're raising the base to. So we're taking a to the second power. Okay, the number on top raises the base to that power. In this case, there's a 2 on top, so you're raising it to the second power. What's on the bottom is what you root it to. So we cube root this. And you're going to see that that's what the book has as an answer, and that's absolutely true. I just want to show you an equivalent form. So I'm gonna box this out, but I also want to just show you an equivalent form of this, which is you could first do the root part, third root of a, and then raise that whole thing to the second power. Doesn't matter which one you apply first. So you could also have that as an alternate answer. But if you wanna be consistent, you can say, let's just raise the base to the power that's in the numerator, and then um, root the whole result. Okay. Now this next one, you can see that the x to the 1/2 power, that is only that exponent of 1/2, that is only on the x. It's not on the 25. So for an answer, we're going to get the 25 is already just all by itself. The 25 looks like that. What's being rooted? What's being rooted is the x. And since it's being square rooted, we don't actually need to write a 2 here. We're not going to put a 2 here, for example. Okay, you saw that in the earlier problems that they put a 2 there, but that's just to show you, they just wanted to kind of show you that they're square rooting it and not rooting it to some other root. Okay, and let me just rewrite that a little bit neater so you can see that. That should look like that. Oops. Okay, so that's the answer. I'll box that. Now you can see for this one, they're actually rooting the entire thing. So how would we write that? We could write that as the square root of everything in there, 25x. The entire base is being raised to the 1/2 power. Now, this is equivalent to this. This is equivalent to square rooting each piece of it. Square rooting 25 times square root of x. And you should know that the square root of 25 is just 5, so that can be simplified to 5 and then times the square root of x. Okay? And I'll box that answer out too. Sorry, I meant to switch colors there, but that's fine. So you can see the difference between those two is that in this one, the 25 is not, in number 19, the 25 is not being raised to that power, so it's not rooted. And here, since there's parentheses around it, that's part of the base. That's part of what's getting square rooted. Okay? Now let's continue on. We can break this one down. We can say that this is the square root of 98d. And actually, if we were to break that down and list everything that's in there, we could say 98 breaks down into 2 times 7 times 7, right? 7 times 7 is 49. 49 times 2 is 98. So, and then times d. So those are all the those are all the pieces that multiply together to be the base of 98d. So then what are we saying? Well, if we see something inside twice, and we see that 7 in twice, we can bring it out once. Why twice? Because it is a square root. That is an implied 2 there. That you don't have to write it, but you should know that it's suggested as there, right? It's implied, and so we say we need to see something twice inside in order to bring it out once. And so what can we bring out? We can bring out the 7, and what stays inside? The 2 times d, or 2d. And that's the answer for that one. 7 root 2d. And finally, this one is an interesting one. We are going to raise this to the second power, 24c, all raised to the second power, and then we're going to cube root the result. Okay, so what I want to do with this one is I want to actually say that's the cube root of 24c times 24c, right? Because that's what it says, you're multiplying it by itself. So we've got 24 times c times 24 times c. Well, what does that actually equal? Okay, what that equals, if we were to break down that 24c, we would say that's the same as, I'll write it here on the bottom, that's the same as the cube root of, how does 24 break down? It breaks down into 2 times 2 times 2 times 3. 2 times 2 times 2 is 8. 8 times 3 is 24. And then, of course, times c. And since we squared that, we're multiplying by itself again. Times 2 times 2 times 2 times 3 times c. And what is our rule? Our rule says that if you are, whatever you're rooting it to, and you can see that we are cube rooting it, right? Third root, means you have to see something inside 3 times in order to bring it out once. So we see 1, 2, we can bring a 2 out. And we have another 3 2s for another 2 that we can bring out. And what can't we bring out? What we can't bring out is the 3c and the other 3c. So when we multiply the 3's together, we get 9. Or actually, I'll write it first as 3 times c times 3 times c. There's not 3 of those in there. So, or there's not 3 3's and not 3 c's. So we got to leave those inside and multiply them back together. And what we get as a result is 2 times 2 on the outside is 4. 4 cube root of 3 times 3 is 9. And c times c is c squared. And that is what you get. Let me get that. Let me do that again. Sorry, I'm trying to clear this out. Not going. That's what you get as a result. 4 cube root of 9.